Hey guys, this is Sean with Alexander Tutoring, and this is a continuation of the factoring video we did last time on factoring quadratics, except this time we're going to do quadratics when a is not equal to 1. What do I mean by that? Well, you probably know already that quadratics all follow this format: a number a times x squared plus a number b times x plus a number c. Okay, so in this example I have above, we can see that a equals 2, b equals 17, and c equals 21. Okay, so you'll notice that a, or the term multiplying the x squared in this example, is not 1, it's 2, whereas in prior examples, the prior video, it was equal to 1. And that makes factoring a lot harder. Believe it or not, this is something we ask tutors in interviews who want to work here, and a lot of them don't get it. So today you're gonna learn to be better than most people who apply here, and you're gonna be able to teach your friends this. Okay, so let's do it. So when we're doing normal quadratics, when a is equal to 1, you always wanted to think of two numbers that add to the middle term and multiply to get the c term. Two numbers that when added together give you b, when multiplied together give you c. Go see my previous video if you have questions on that. So when a is not equal 1, there's a slight addition to that rule. So we still want two numbers, I'll call them y and w, two numbers that when added together give you the middle term, 17, but when multiplied together, this time we want them to multiply to give us the product of the a and the c term, which in this case is 2 times 21, or 42. Okay, so we want two numbers that when added together give us the middle term, the b term, 17, and when these two numbers are multiplied together, we want them to give us the product of the a and the c term. In this case, 2 times 21 is 42. What are these two numbers? Well, I'm going to use a technique really similar that I did on the other video, and that is we're going to start by finding numbers that multiply to get 42, okay? And I always start with the factor of 1, because everything times 1 is itself. So 1 times 42 is 42. Those are two numbers that multiply to 42. But I think you can see from seeing them next to each other that there's no way we're going to get a 17 out of those two numbers, right, by adding or subtracting them. So what I like to do next is click the 1 up to a 2. 2 times what is 42? Well, 21. And looking at 2 and 21, I can see there's no way I'm getting a 17 by adding or subtracting 2 and 21, so that doesn't work. So I'm going to click the 2 up to a 3. 3 times what equals 42? The answer is 14. And now it should be pretty obvious that, look, I can get a 17 by adding 14 and 3 together. So those are the magic numbers that add to the middle term, 17, and multiply to get the product of the a and c term, in this case 42. Okay, so what are we going to do with those two numbers? We're going to split the middle term. So we're going to go 2x squared. The 17x, we're going to write it as 14x plus 3x, and then the plus 21 we're just going to leave there. So I used these two numbers we came up with, the 3 and the 14, to rewrite the middle term. 17x is 14 plus 3x. I didn't tell you what number order to do those in, and I'm going to explain why I did put the 14 first in a second, but let's see what the next step is. The next step is a process called grouping. Grouping is when we look at just the first two terms. In this case, it would be the 2x squared plus 14x. And we're going to factor everything we can out of just those two terms. So what's common to both those terms? There's a 2 common, and there's an x common. Leaving behind x plus 7, right? If we just factor the first two terms, 2x times x is 2x squared, 2x plus times 7 is 14x, okay? We're going to keep this plus sign in the middle, and now we're going to factor just the second two terms. What's common to 3x and 21? We can pull a 3 out, we get x plus 7. And you'll know you did it right when you get the same thing here and here. So now we have two terms left, and terms are separated by plus and minus signs. We have this term here and this term here. What's common to those two terms? Well, the x plus 7 in parentheses is, so we can actually factor that out. Okay. What's left behind over here? The 2x plus what's left behind over here? The 3. Boom. We are factored. Okay. So I hope that was helpful. And just really quickly, again, Alexander tutoring, it's never enough to just memorize a rule. I told you we were going to think of two numbers that add to get to the middle term, 17, and multiply to get the product of the A and C term, which is 42. The numbers that did the trick were 3 and 14. Why did we do all that? Well, I think the easiest way to see it is if we distribute this thing again. And we can see what happens when we distribute it. Okay, so when distributing, we do this times this, right? Or FOIL. Okay, so you can see that we get the 2x squared. That gave us the 2x squared back, right? Now we do x times 3 is plus 3x. Oh, 3. Okay, now we do the 7. 7 times 2 is 14x. Okay, do you see how we got the 3x plus 14x? That's why we want to think of two numbers that add to 17x. Because we're in the distributing process, we can see that these are going to add up to the middle term. And then finally, we can see that this will also restore when we get to 7 times 3 plus 21. That restores the C term. We can add 3 and 14x together. We get 17x plus 21, back where we started. All right, I hope that helps. Show your friends how to do it, and have a great one. Take care.